Okay. So the next type of operator that we come across is bitwise operators. The next type of operator is bitwise operators. Bitwise operators. Okay. So what are bitwise operators? Basically, right, these operators perform operation at binary level, right, at machine level or binary level. Okay. So how many types of bitwise operators are there? The first one is bitwise and. The first one is bitwise and. It is represented by a symbol called as and. So how do you perform the AND operation, bitwise AND operation, right? Let us take an example here. Okay, it's a binary operator. Okay, let us take an example. Int A is equal to 5, B is equal to 8, comma, result. Okay, so res is equal to A bitwise AND of B. So basically, how does the operation takes place? Let's look at explanation. Let's look at explanation. Okay. So what is the value of A? The value of A is 5. And the binary of 5 is 0101. Okay. And B value is how much? It is 8. Binary of 8 is 1000. So you need to perform the AND operation. So now start doing the AND operation from this side. From this side we will start doing the AND operation. If you do the AND operation of these two bits, the result will be 0. This one will be 0. This one will be 0. This one will be 0. Now convert this into decimal. Convert this into decimal. So the value stored in the variable res is, right, in the res is 0. The value stored in res is 0. So this is what is the, right, bitwise AND operation. These operations are carried out at a, right, binary level. Now similarly, if you look at right, if you look at, right, bitwise or operation, bitwise or operation, bitwise or operation, it is represented by this symbol. Okay, you take an example here, right? Okay, int A is equal to 12 and B is equal to 5. Okay, and res, right? Now if you go with this example, as I've told you that bitwise operators work at binary level. So let's look at explanation here, right? This is the explanation part. Now what is the example? We will write res is equal to A bitwise or of B. Now what is the A value here? A value is 12 and the binary of 12 is 1100. Binary of 12 is 1100 and B value is 5 and the binary of 5 is 0101. Now you need to perform the OR operation. So, right, if you perform the OR operation from this side, right, you know that OR gate, if any one input is right 1, the output will be 1, 0, 1, 1. Okay, if you look at this decimal equivalent, it is 13. Decimal equivalent of that is 13, right? So res will contain a value called as 30. This is the result present in res. All the operations are carried out at binary level, right? This is how these operators work. Are you understanding? Are you guys understanding? I'll tell you why they are used, Gavin. I'll come to that why they are used. Okay, in the last I'll come to it why they are used. So I hope you guys are understanding. All of you are understanding. Okay, very good. Okay, now coming to bitwise not. Coming to bitwise not. Okay, bitwise not is represented by tilde symbol. Right, the symbol name is tilde. Right, symbol name is tilde. Okay, so you take an example here, right? Because this bitwise not is a unary operator, it is a unary operator. So you take an example here, right? Int a is equal to 7, right? Int a is equal to 7, right? Now res is equal to, right, res. So res is equal to negation of a. If you do this, what exactly will happen, we need to understand. Okay, to explain this I need a little more space. Now if you look at the data type of integer, what is the data type of this variable a? The data type of variable a is integer, correct? The data type of variable a is integer. So the size of integer is 2 bytes. Okay, now, right, now if you take the binary of 7, right, that 7 needs to be represented in 16 bits, right? We need to represent it in 16 bit. So this is the binary of 7. Since the memory allocated for a variable is 2 bytes, the memory allocated is 2 bytes, that means it can store 16 bits. Okay, now if you put a value in the variable a, we need to write the binary form in the 16 bits only. This is how we need to write it. Now you will have a question, sir, why did not we write here? Right, in these operation we did not require these zeros, all of them are zeros, so we did not require these zeros. So what we did, we ignored those zeros. But when it comes to this, so one's complement example or bitwise not, right? So when you apply a bitwise operation on this one, bitwise not, right, this will flip all the bits. 0 becomes 1 and 1 becomes 0, right? 0 becomes 1 and 1 becomes 0. Now we need to find out the binary of, sorry, decimal equivalent of this number. We need to find out the decimal equivalent of this number. Now I'll teach you the conversions later onwards. Okay, binary to decimal. Okay, let's take I'll write down the binary number here: 4 ones, 4 ones, 4 ones, 1 triple 0. Convert this binary to decimal number, which is equal to, no, this is not correct. Binary to decimal number. Write the binary number here: 4 ones, 4 ones, 4 ones, 1 triple 0. Convert. So it is 65,528. So this is what will be stored in the 65,528. This is what will be stored in res. 65,528. This is called as ones complement. Bitwise not is also called as, right, bitwise not is also called as ones complement. It's also called as ones complement. Are you understanding, or do you guys have any doubts here? Yeah, you can write the binary of 7 as, this is the binary of 7. Okay, 0 triple 1. But why are we writing all these bits? Because, right, since we are applying ones complement, the bit which are present 0 here, they will become 1. So in order to find out the actual value of res, right, we need to write down all the 16 bits. Why all 16 bits required? Because the variable what we have declared is integer, and the size of integer is 2 bytes. Are you understanding? Is everybody clear on this part? Right? Yes, 65,536. Yes, Gavin. It is close to 65,536 minus 7. Right? Basically, what happens is, right? I'll give you one example. Okay, I'll give you one example. Okay. Now, there is a variable called as, okay, are you clear with this part? Okay. Please all of you reply with a message. How to do conversions? Don't worry, I'll teach you conversions also. Right now, see here. Okay, before going that, right, let's convert binary to decimal. How to convert binary to decimal? Okay, binary to decimal. So let's say the binary number is, right, this is my binary number. Okay, 0 0 0 0 0 0 0 1 0 0 1 0 1 1. This is the binary number. Now if you want to convert this to decimal, what we need to do is first write down the index here: 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. So the numbers which I have written in the red color, they are called as bit positions. Bit positions. They are called as bit positions. Okay, here what happens is, wherever the bit is 1, wherever the bit is 1, you write it as 2 to the power bit position number. 2 to the power 0 plus 2 to the power 1. Now you look at this: 2 to the power 1. Okay, and look at this now, right? 2 to the plus 2 to the power 3 plus this one, 2 to the power 6. So 2 to the power 6 is how much here? 32. Sorry, 2 to the power 6 is 64, plus 2 to the power 3 is 8, plus 2 plus 1. So, right, how much is that? 74, 75. So this is the binary of 75. Are you understanding how to convert the binary number to decimal? Is everybody understanding? For which one then? In the or part, the answer will not be 13. See, in the or part, let's take an example of or. Let's take an example of or. See, in the or operation, what we are doing is, right, all remaining bits which are present on this side, all of them will be 0. It won't make any difference, right? If you take this example, the answer is 13. That is correct, because remaining bits which are present on this side, they are 0 only. 0 or 0, it will remain still a 0. Are you understanding, Gavin? Sorry, Srinidhi. It will be 13. It will be 13. If or operation, if I take or operation here, what's a binary of 12? Binary of 12 is this. Okay. So binary of 5 is how much? 0 0 0 0 0 0 0 0 0 0 0 0 1 0 1. You perform OR operation here, it is 1 0 1 1, and all these bits will be 0. All these bits will be 0 after the OR operation. Now if you convert this 0 1 2 3, 2 to the power 3 plus 2 to the power 2 plus 2 to the power 0, which is equal to 2 to the power 3 is 8 plus 4 plus 1, which is equal to 13. That is what we have got here. Srinidhi, are you clear? We get the same answer. Since all of them are 0, we ignored it because it will not affect us when we are doing operation. But when it comes to not, you can observe that the bits are changing after the operation, right? The bits are changing after the operation. That is the reason we need to write all the bits. If the bits are changing, right, during the operation, you need to write all the 16 bits. So everybody is clear on bitwise and bitwise not and bitwise or and or not, and also converting binary to decimal. Is everybody clear on that part? Okay. Okay, very good. Now what we will do is we will go with some more operations. Fourth one, bitwise XOR. Bitwise XOR. Okay, this is one of the amazing operator which we have in the language. The most what do you call interesting operator. So bitwise XOR is represented by caret symbol. This symbol is called as caret. Some people call it as a cap. Students will call it as a cap, right? Now, first we need to understand the table of XOR, right? When does the output of XOR will be true? When does the output of XOR will be false? That we need to understand. Okay. So let us take A as an input, right? A as a one input, B as a second input. Now, if you perform A XOR B, okay. Now, so inputs are 0 0, 0 1, 1 0, 1 1. These are the inputs. So the output of XOR will be, see, when both the inputs are same, when both the inputs are same, and remember this, when both the inputs are same, the result is, right, 0, false. When both the inputs are same, the result is false. When both the inputs are different, the result is true. Okay, when both the inputs are same, right, the result is 0. When both the inputs are different, the result is true. I'll write down here note, right? If both input are same, if both input are same, result is, right, false. Okay, if both input are different, then different result is true. Are you understanding? Right, result is true. Now this is one point, this is another point. Okay, are you clear on this part? Okay, so the table is clear. When both the inputs are same, the output is false. When both the inputs are different, the output is true. So this is how it works. Now if you take an example here, right, This, if you take an example here, okay, here int a is equal to, right, 10, 10, and b is equal to, right, okay, b is equal to 6, and the result, okay. Now res is equal to a xor b, right, a xor b. Now what is the a value here? A value is 10, and the binary of 10 is 1010, and b value is 6. What's the binary of 6? 0110. Now if you perform the bitwise XOR operation, if you perform, right, the bitwise XOR operation, when both the inputs are same, the result is 0, again 0. Now it is true, now it is true. Then you convert it to decimal, it becomes 12. So this is what is stored in res. This is what is stored in res. So are you understanding? Are you understanding? They are defined that way. They are defined, the gates are defined that way. Gavin, the gates are defined that way, right? And gate, or gate, not gate. That is the way they operate. They are designed in that way. Okay. Now, if I take one more example here, if I take one more example here, int a is equal to 8, comma b is equal to 8, comma res. Can you tell me what is the res value if I perform a XOR b? Let's see who is quicker. What is the result of? Hey, nice one. Come on, dude. All of you. Come on, guys. A value is 8. B value is 8. Read the note. When both the inputs are same. Exactly, Shaina. If you go with a decimal value, it will be obviously 0. Correct? When both the inputs are same, the answer will be obviously 0. Isn't that correct? Everybody understood now? Now, this property, right? These two things, what we have written here, these two properties are called as toggling effect. Toggle effect. Toggling means switching one place to another place. There are two places, right? Right? Switching between those two places. This is the kind of, this XOR operator will create that effect. This is the kind of effect it creates. Okay, this is the kind of effect it creates. Now, next part is, right, write a program, write a program, okay, to swap two values, two variables without third variable, without third variable. You should not use any extra variable inside this, right? For example, let's take example, right? Int a is equal to 5, comma b is equal to 8. Now I want to change these values. I want to swap these two values without using third variable or extra variable. But if you use an extra variable, what you will do, right? When we are using extra variable, right? How do we do it, right? How do we do it if we are using extra variable? First, what I will do, I'll put a value into temp. Now, how do you write that? Temp is equal to a, correct? And then put b value into a. So it becomes 8. How do you put b value into a? A is equal to b. And then put the temp into B, right? So B is equal to temp. So this is how you swap using extra variable. Now the condition is you can't use extra variable. You can't use extra variable. That is our question, right? Are you understanding? We should not use extra variable. Then how we can do it? Solution, right? A is equal to A plus B. So there is a variable called as A which contains 5. There is variable called as B which contains 8. Now find out what is A plus B. A plus B is 13. Where are we storing it? Into A. So new value of A is 13. Okay. After that, B is equal to A minus B. So what is the A value now? A value is 13. 13 minus B value is 8 is 5. Where are we storing it? We are storing it into B. So it is 5. Next, right? A is equal to A minus B. So what is A value? 13 minus 5, right? Where are we storing it? We are storing it into variable A. So which is 8. Are they getting swapped? Are they getting swapped? Are they getting swapped? We will write a program also. Don't worry. Okay. Are you understanding? Now, since we have learned, if you have learned this, I'll start the next part. If you have understood, I'll start the next part. Can I? Okay, Gavin. What about others? She clear. Okay, everybody is clear. Very nice. Now, what we will do is there is another solution, right? There is another solution, right? Another solution, right? That is, we can make use of XOR using XOR. Now, as we know that XOR gives us, right, switching places here and here. It will help us to, right, switch the places, toggling effect. So what we can do is the logic here is, right, the logic here is A is equal to A XOR B, B is equal to A XOR B, A is equal to A XOR B. These are the three statements, right, which will help you to swap the data, right? Now, if you want me to take A and B values, let us take A is equal to 8, comma B is equal to 5. Okay, we are roughly writing it here. Okay, I'll tell you how to write it in exams also. We are just learning logic. Okay, now, so what is A value? A value is 8. Binary of 8 is 1 0 0 0. What's a B value? B value is 5. Okay, let us execute the first expression. Okay, B value is 5 0 1 0 1. When both the inputs are different, right, the output is true, correct? So this is equivalent to 13. So where are we storing that 13? We are storing it into a variable called as A. So new value of A is how much? 13. New value of A is 13. Now next time what we have to do? So this one job is done. Okay, this is one job done. Now this becomes the new value of A. Okay, now second operation, A XOR B. So A value is 13, B value is 5, B value is 5. So if B value is 5 0 1 0 1, perform the XOR operation, right? When both are same, result is 0, both are same, result is 0, both are same, result is 0, and then 1. So this will be stored into which variable here? This will be stored into B variable, and its decimal equivalent is 8. So it is stored in B. It is stored in B. Okay, So b value becomes 8. B value becomes 8. Now, right, this is second step. Okay. Now, right, you need to perform third expression, a XOR b. So b value is 8. What is a value? It is 1101 13. A value is 13. Perform the XOR operation 1 0 1 0, and its decimal equivalent is 5. Where are we storing it? Into A. So its value becomes 5. Now don't you think the values are swapped? Now don't you think the values are swapped? Correct? Is everybody understood this part? Okay. Very good. Very good. Okay. Now, how to write a program for this? As I've told you yesterday, right? Inside main function, how many steps are there? Only 4 steps. Declare variables. Second step is read input. Third step is compute task and print result. This is the outline of the program. Any program you take, this is the outline of the program. Okay. Now what we will do is we will write a program logic for swapping of two numbers without third variable using XOR. Okay. So what are the steps here? First step is declare variable. First step is declare variables. Okay. Second one is read input. Okay. Third step is print inputs before swapping. Okay. Print inputs before swapping. Then compute task. Fifth step is print, right? Sorry, print variables, not inputs. Print variables before swapping, then print variables after swapping. So that why we are doing these two jobs? Why are we doing these two jobs? Because on the output screen it becomes easy for a user to compare and understand my logic is working. That is the reason we write like that. Okay. Now let's go for the compiler and start writing. GDB online compiler. Okay. GDB online compiler. Okay. GDB online compiler. Okay. So what is the first step here? Declare variables. I need one variable and another variable to store input, and another variable. We don't require any other variable. Okay. Only we need two input. We need to swap them without using extra variable. So printf. Okay. Printf, enter two numbers. Okay. Then scanf, right? Percentage d double quote comma. First input will be stored in A, second input will be stored in B. So two steps are finished: declaring variable and reading input is finished. So what is the next step here? The next step is, right, what is the next step? Third step, print the variables before swapping. So printf slash n before swapping. It is a message. So a is equal to percentage d and b is equal to percentage d slash n. So in place of first percentage d, we have to print the a value. We have to print the a value. In place of second percentage d, we have to print the b value. Okay. Now the next thing is, right, before swapping we have printed a and b values. Now swapping logic. What is the swapping logic? A is equal to A XOR B, B is equal to A XOR B, right? And A is equal to A XOR B. After these three steps, now I need to print the result after swapping. So I will copy paste that line and change this sentence to after. My program is finished. My program is finished. Are you clear on that part? So let us execute it and give the inputs 10 and 15. So before swapping, the values of A and B are 10 and 15. After swapping, 15 and 10. Are you clear on that part? I'll keep this program in the file if you want. Here, text file, so that you can use it for learning in the later part. Okay. Okay. So is everybody clear on this part now? Basic one example I showed you how to write a program. All of you, what you guys have to do is you need to remember this part. You need to remember this general steps for writing any program, right? Okay. Now moving on to next part. Okay. So can I go for the next part? So there are two more bitwise operators are there. Let's learn them. Okay, two more bitwise operators are there. Let's learn them. So fifth one is bitwise left shift. Bitwise left shift. Okay, bitwise left shift. Okay, so what is the symbol of this? Bitwise left shift operator symbol is like this. Okay, now what is the syntax of writing shift operation? So syntax is right, right, number left shift by B. Okay, so number is right, integer number on which shift is done. Is done Shifting is done. So whereas B indicates number of bits to shift. Okay, B indicates number of bits to shift. Okay, let us take one example here. Okay, so let us take int num is equal to 2 and B is equal to 1. Okay, so what is the number here? Given number is 2. So binary of 2 is what? 4 zeros, 4 zeros, 4 zeros, right? And 30, sorry, 0010. So this is the binary of, okay, 2, 16 bits. Okay, now I need to shift the bits on the left side. So I need to shift every bit on the left side like this, right? If I keep on shifting every bit on the left side, now don't you think this bit will be lost? This bit will be lost, right? So every bit gets shifted here, 0 0 0, and this 0 will come and join here. Okay, and three zeros from here, and this 0 from will join here. Now three zeros here, and this 0 will come down here. Now 0 1 0. Now what will happen is new 0 will be added on the right side. New zeros will be added on the right side. So now if you convert this into decimal, Now if you convert this into decimal, this will be, sorry, this will be, right, 4, right? So if I write something called as equal to res is equal to num left shift by b. So what does the res will contain? Res will contain 4. Is everybody understanding? Left shift operation. Every bit will be shifted by one position on the left side. Every bit will be shifted, right, on the left side by one position. Are you clear on that part? Okay. Okay. Now, so now you take one more example. Okay, one more example here. Example 2. Okay, let's take int num is equal to, right. Okay, I'll just write down direct values here. Now if I write 4 left shifted by one more bit, so what's the binary of 4? 0 1 0 0. Okay, if I left shift every bit on, if I shift every bit on the left side, this will become 0 1 0 0. So what is the result? It becomes 8. The result it becomes is 8. Now if I take 8 left shifted by one more bit, right, it becomes 1 4 zeros. It becomes 16. Now think, the one which is present here, it will come down to this place. So the value becomes, or the result becomes 16. I have not written zeros on this side because it will waste my time and your time as well. Actually the binary of these numbers are like this only, 0 0 0, like that. Okay, now if you observe a pattern, if you observe a pattern, I took 2 and shifted it by one time. So what is the result? It becomes, result it becomes is 4. Okay, I took 4 and left shifted it by one time, the result it becomes is 8. If I take 8 as an input, left shift it by one more bit, the result becomes 16. So in short, right, in short, right, every, right, when we shift, when we left shift number by one position, the number gets multiplied by 2. The number gets multiplied by the number gets multiplied by 2. Are you understanding? Every time you left shift one bit, it becomes double or it gets doubled. So, right, there is a formula to get the answer. There is a formula here. If you are having number left shift by b, if this is the syntax, now you can use a formula to get the result. To get answer, to get answer, you can use a formula directly, number multiplied by 2 to the power b, number multiplied by 2 to the power b. You can directly use, right, this formula to get an answer. So for example, I will take 2 left shifted by 3 times, right? So if I do that, right, 2 multiplied by 2 to the power 3, which is equal to 16. Now can you see here, I took 2 left shifted by, left shifted it by 1, 2 and 3, and the result we have got is 16, right? So you can directly use a formula, right, to get the answer for these. Is everybody clear on this part? Okay, are you? Everybody. I meant everybody. Are you clear on that? Okay. Very good. Very good. Okay. Very good. Now we will go with a right shift. Okay. Now we will go with right last one, right shift operator. Right shift operator. Bitwise right shift or bitwise right shift operator. You can call it any way you want. Now it's exactly instead of division this time, sorry, instead of multiplication, this time the division will occur. Now if you look at the syntax, right? If you look at the syntax, right? Number right shift by b. So number is nothing but it's a integer number, sorry, integer number on which shift is done, okay, where p indicates number of bits to shift on the right side. Okay, you take an example here, right? Int a is equal to 8 comma b is equal to 1, right? So what is a binary of 8? 1 0 0 0, right? Now this time what will happen? This bit will be lost and every bit will be shifted to this side, okay, and a new zeros will be added on the left side, so it becomes 0, right? 1 0 0, and its decimal equivalent is 4. Now you shift, right? Now you take another example, example 1, sorry, this is a left shift by b. Now you take another example, int a is equal to 4, b is equal to 1, right? If you do a left shift by b, right? Okay, I need to take one more variable here, res comma res is equal to res is equal to, okay. So now if you look at this, right, now this bits will be shifted like this, right, and this becomes 2. Now every time you right shift a bit, every time you shift a number on the right side, right, every time one bit is shifted, right, on the right side, right side, the number gets divided by 2. The number gets divided by 2, okay. In short, it becomes half. In short, it becomes half. So you can use a direct formula here. You can use a direct formula for right shift. If the syntax is num right shift by b, sorry, I have to write right shift. By mistake, I had written left shift. Okay, I had to write a right shift here. Symbol was wrong. I have corrected it. Now this can be, right, you can get the result of this operation, right? Num divided by 2 to the power b. Num divided by 2 to the power b. You can use that formula to get the result. Okay, you take an example, right? Int a is equal to 8, b is equal to 3 bits, and res is equal to, right, a right shift by b, a right shift by b, right? So you can calculate with a directly a formula, 8 divided by 2 to the power 3, right? The result is 1. That is what gets stored in RES. This completes bitwise operators. Are you clear on this part? Any doubts till this point? Okay. This completes most of your operators. There are only few are remaining. Let's conclude them. Okay, we will finish all of them. Okay, so the next type of operator is, right, conditional operator. Conditional operator. It is also called as ternary operator. So it is a operator which works on how many operands here? Right, it is an operator which works on how many operands? Ternary operator works on how many operands? Right, it works on 3 operands. It works on 3 operands. Right, now let us look at the syntax. Okay, let us look at the syntax of this. Okay, okay, so the syntax is expression 1 question mark, expression 2 colon, expression 3 ends with semicolon. So first of all we need to understand here expression 1 is always considered as condition. Expression 1 is always considered as condition. Expression 2, right, right is executed if condition is true. Okay, expression 3 is executed if condition is false. Okay, so I'll take one example here to make you guys understand. Okay, let us take an example here. This is the syntax. Let us take an example to make you understand. Int a is equal to, right, 17, b is equal to 32 comma res. Okay, right, so res is equal to a greater than b question mark a colon b. Now, as I've told you that the first expression is always treated as condition, right? So I have written a condition as a greater than b. Is it true or false? 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 Condition is false. So if the condition is false, right, then b will be assigned to res, right? So b will be assigned to res, right? B will be assigned to res. So res value will be, right, res value will be 32. Okay, you take another example here. Okay, right, int a is equal to 17, or let's take a is equal to 59 comma b is equal to 24 comma res. Okay, now, right, res is equal to, right, a greater than b question mark a colon b. Now the condition is a true or false. Now the condition is a true or false. In this situation the condition is true or false. It is true, correct? A greater than b. A value is 59, b value is 24. Now tell me, this condition what we have written, it is true, isn't that correct? So if the condition is true, then a will be assigned to res. A will be assigned to res, right? A will be assigned to RES. A value is how much? 59. Okay. Just for explaining the syntax. Only for explanation. Only for explanation. Okay. Only for explanation. Okay. See, RES is equal to expression 1 question mark expression 2 colon expression 3. Okay, this is what I have taken. So the first one always acts as a condition. So if the condition is a true, if this condition is true, then expression 2 will be assigned to RES. So if the condition is false, then expression 3 is assigned to RES. Just like if else. It is similar to if else. Okay. I'll just take one more example here. Okay. Just to give you more clarity and some more information, added information. Let's take an example. Int A is equal to 15, comma B is equal to 8, comma RES. Now RES is equal to minus 9 question mark A colon B. Now can you tell me the condition is true or false? Condition is true or false. My condition is minus 9. My condition is minus 9. How do you decide true or false? How do you decide true or false? There are boolean values, right? 0 means what? What is the meaning of 0? Huh. Arey, come on, all of you. 0 means what? What do we consider 0 as? 0 is considered as false. Isn't that correct? Now, a non-zero is considered as what? Non-zero numbers are considered as what? True. Correct. Very good. So right now in my condition place, what do we have here? We have a non-zero number. Now tell me the condition is a true or false? We have a non-zero number in the condition. So the condition becomes what now? Condition becomes true. If it is true, what will be the RES value? RES will contain what? 15. Correct. Non-zero, right, is treated as true, right? If in place of this, if I have 0 here, in place of minus 9, if I had 0, condition will be treated as false, right? Is everybody understanding? There is no rule that condition means, sir, A greater than B, or A not equal to B, right? Or A less than B. There is no rule that condition should be like this, right? Whatever you write in this place, you have to use it for evaluating condition. Since I have written non-zero number, non-zero means it is true. If I write 0 there, the condition becomes false. Are you clear on the ternary part? Are you guys clear on the ternary part? Very good, very good, very good. Okay. Now, there are one or two more operators are there, right? Now, next type of operator is, right, shorthand attack, shorthand assignment operator. Shorthand assignment operator. So what is the meaning of shorthand assignment operator? Generally we call it as shortcut. Shortcut way of writing expressions. Shortcut way of writing expressions. I'll show you example, right? A is equal to A plus B can also be written as A plus equal to B. Shortcut way of writing. So now this part what we have is called as shorthand and operator. Shorthand assignment operator. Are you understanding? So like this, you can write it as A is equal to A into B, can also be written as, right, A into is equal to B, right? Are you clear on the shorthand assignment? Shortcut way of writing, because nowadays the people are very lazy. Nowadays the people are very lazy. So Dennis Ritchie sir has given us a flexibility to write a shortcut way, right? Next one is assignment operator. Assignment operator. Okay. Assignment operator. The symbol is this. Okay. So this is called as LHS is equal to RHS. Always remember assignment happens from right side to left side. Note, right? Assignment operator works from right side to left side. That's it. Whatever is, for example, you take here int a is int a comma b is equal to 15. If I write a is equal to b, whatever is present in b, right, whatever is present in b will be copied into variable a. That's it. This is how the copying happens, right? Okay, this is called as assignment operator. This we have learned from childhood, isn't that correct? We have learned this from childhood. Okay, so the last category of operators is, right, last category of operators is, okay, sorry, special operators. Special operators. Okay, now in this one, basic two, there are two basic operators we consider. One is comma operator. Okay, why do we use comma operator? It is used to separate variables of same type. Okay, for example, if you take an example here, okay, int a comma b comma c comma d. This is how we use, right, this operator to separate the variables of same data type. So this is called as comma operator. And the second one is, right, size of operator. Size of operator. Okay, size of operator. Now many students have a problem. Size and of, this is how they will write, which is wrong. There is no space here. You should not give any space. You should write it continuously. It is used, it is used to find memory consumed, memory consumed, consumed by variable or data type, or size of data type, size of data type, right, size of data type. And also you need to remember that it returns value in bytes. It returns the value in bytes in 16-bit compile. sorry, it returns the value in bytes, that is integer format, in 16-bit compiler. Okay, in 32-bit compiler it will return long int in 32 bit. In 32-bit compiler it returns long int. In 16-bit compiler it returns integer. Right, now let us take an example and understand. I'll just write one example. Okay, I'll just take one example here. Hash include stdio.h int main opening bracket. I will declare int a, float b, character ch. Okay, I want to print the value memory consumed by all these data types. Okay, so printf int is equal to percentage d, comma, float is equal to percentage d, and character is equal to percentage d, double quote comma. So first one, I need to print the size of a variable. So what I will do here, I'll write size of a. So whatever value it returns, it will be printed in the first percentage d place. Then size of b, then size of ch, size of ch. Okay, now if I execute this code, you will see, right, you will see, right, one warning message. You will see a warning message here. See, warning, format percentage d expects argument of type int, but the argument 4 has type long unsigned int. So we need to give here the format specifier as ld, because the compiler which we are using is 32-bit compiler. The compiler which we are using here is a 32-bit compiler. Then I have to give percentage d. So size of integer is 4 bytes, size of float is 4 bytes, size of character is 1 byte. Now, is everybody clear on this part? Any doubts till this point? Now all of you, what you guys have to do is, you guys have to